So today we will discuss about short note on sparse PCA or sparse PCA. Okay. So as in previous lecture we have discussed about the PCA, that is principal component analysis, and why it is used, where it is useful, right? So where the PCA useful, that is principal component analysis, when the data size is large and the features that is to be made up with the data set is very high. At that place the problem of overfitting occurs, right? So to overcome the problem of overfitting we are using the principal component analysis. Okay. Now why it is useful and how we have seen the example also based on that, right? Now here we are going to see the sparse PCA. So as we know, the scikit-learn, which is the library of Python, provides the different PCA variants that can solve particular problems, right? Now sparse PCA come into picture when we think about the handwritten digits or the images that must be classified. So if you want to classify the handwritten digits or the images, then the sparse PCA come into the picture. So because their initial dimensionality can be quite high. However, applying a standard PCA selects only the average most important feature. If we apply the standard PCA on that, it will select only the important features, assuming that every sample can be rebuilt using the same components. Simplifying this is equivalent to YR is equals to C1 YR1 plus C2 YR2. This is the simplification. सो कब स्पार्स पीसी हम लोग यूज़ करेंगे? अगर हमें हैंड रिटन डिजिट और इमेज को अगर क्लासीफाई करना है उसकी जिसकी डायमेंशन ऑलरेडी हाई है, तो वी आर यूजिंग द स्टैंडर्ड पीसीए टू सिलेक्ट द इम्पोर्टेंट फीचर, जो कि हम लोग अज्यूम करते हैं every sample can be rebuilt using the same component. Now what is the same component means? The principal components that we are finding to reduce the dimensionality, right? So from that principal component, the average most important component we are selecting, and we are rebuilding other component based on that particular component. So that simplification is equivalent to this formula. Okay. Now on the other hand, we can always use a limited number of components. As we know, the number of principal components that we are deriving, that should be limited, means it is less than or equal to the number of features available in that particular data set, right? But without the limitation given by dense projection matrix. Okay, now what is the dense projection matrix means? Dense means what? Compact projection matrix. Now projection matrix we already saw, right? Because we are displaying that features in the form of matrices, that is nothing but the matrix, right? Now dense means what? That matrix becomes the complex one, right? Means there are too many features included in that. So this can be achieved using the sparse matrices or the vectors, where the number of non-zero element is quite low. So in this way, each element can be rebuilt using its specific component, which can include elements normally discarded by dense PCA. So this now what is dense PCA means? what कि नॉन ज़ीरो एलिमेंट पहले उसमें से क्या करेंगे? डिस्कार्ड कर देंगे, और बाकी के जो भी एलिमेंट्स है दैट विल बी रिबिल्डेड यूजिंग द important element that we have selected. So now here that equation becomes like this. Here the non-zero element becomes separated, and the zeroth element becomes separate. So that's why that expression becomes like this. Okay, so using dense PCA. Now here the non-null components have been put into the first block, and while all the other zero terms have been separated, as we discussed right now. So in terms of linear algebra, the vectorial space now has the original dimension. However, using the power of sparse matrices provided by your spicy.sparse, this is the library of Python which provide this sparse matrices, can solve this problem much more efficiently than the classical PCA. So classical PCA means what? Whatever the example that we saw in the last lecture, that is nothing but the example of classical PCA. Now here is the sparse PCA, where if you want to distinguish between or classify between the digits or high dimensionality picture, so there it is useful. So the following snippet shows a sparse PCA with 60 components, means 60 features we can say. So in this context, there are usually called atoms. The amount of sparsity can be controlled via L1 norm regularization. Okay, so here some snippet is given which distinguish the between the 60 components, means 60 features. Okay, so it will decompose it like this. The SPCA means sparse PCA is equals to sparse PCA, n component is equals to 60 and alpha value 0.1, which is the constant we can say. So XPCA is equals to SPCA dot fit transformation we are visiting that digit dot data divided by 255. So SPCA dot components dot shape, it is in shape किसके बीच में ड्रॉ होगा अभी 60 components by 60 components, right? So इसीलिए यहाँ पे 60 and 64 लिया है. Clear? So this is all about the sparse PCA. Now next point is dictionary learning and its application. So that is the point, that is dictionary learning and its application. The question can be asked on that point like this: what do you mean by the dictionary learning and what are its application? So what is dictionary learning then? It is a technique which allows rebuilding a sample starting from the sparse dictionary of items. ये डिक्शनरी लर्निंग क्या करती है कि अलाउ करती है रिबिल्डिंग a sample starting from the sparse dictionary of items. Okay, now online strategy adopted by skitlearn, which can be summarized as a double optimization problem. Now where x is equals to, these are the elements of your data set, so is an input data set and target is to find both a dictionary D and a set of weights for each sample. मीन्स हमें क्या करना है, इनपुट डेटा सेट इज़ गिवन, हमें डिक्शनरी भी फाइंड आउट करनी है और उसके हर एक सैम्पल के लिए कितने वेट्स अलोकेटेड है, दैट आल्सो वी नीड टू फाइंड आउट. ठीक है. नाउ डिक्शनरी एज वी नो कि डिक्शनरी में क्या होता है कि हर एक का मीनिंग दिया रहता है एंड मीन्स वर्ड्स एंड उसका मीनिंग दिया रहता है. सो लाइक यहाँ पे अगर फीचर लेते हैं तो उसके रिलेटेड जो भी एट्रीब्यूट्स है उसके दैट इज़ गिवन इन द डिक्शनरी. ठीक है. सो दैट्स व्हाई वी हैव टू बिल्ड अप द डिक्शनरी एंड द सेट ऑफ वर्ड्स फॉर ईच सैम्पल. सो डिक्शनरी में क्या होगा, हर एक फीचर्स के जो भी एट्रीब्यूट्स है वो सारे स्टोर हो गए, सो दैट वी कैन, अगर हमें कुछ चाहिए तो वी कैन फाइंड इट आउट फ्रॉम दैट डिक्शनरी. ठीक है. आफ्टर द ट्रेनिंग प्रोसेस एन इनपुट वेक्टर कैन बी कंप्यूटेड एज लाइक दिस. The optimization problem, which involves both D and alpha vector, can be expressed as the minimization of following loss function. अगर उसमें कुछ मीन्स ऑप्टिमाइजेशन प्रॉब्लम मीन्स व्हाट, अगर उसमें कुछ डेटा लॉस होता है तो डेटा लॉस कैन बी कंप्यूटेड यूजिंग द लॉस फंक्शन लाइक दिस. So here the parameter C controls the level of our sparsity, which is proportional to the length of L1 normalization. This problem can be solved by altering the least square variable until a stable point is reached. जब तक सारा लॉस कवर नहीं होता है एट तब तक ये फंक्शन जो है वो वर्क करेगा. दैट इज़ ऑल अबाउट डिक्शनरी लर्निंग. So dictionary learning application can be used in the PCA also to अगर ट्रेनिंग डेटा सेट दिया है या मैट्रिसेस दिए हैं टू read it from the starting point, it can be used there also. So this is all about the dictionary learning, and here we are going to stop today, and here we can say the second unit of the machine learning is completed.